geobyte.
Similarly, let's take the another important problem. Okay, look at the screen. It is asking like this. The bulk modulus of a spherical object is B if it is subjected to uniform pressure P. The fractional decrease in its radius. It is given the bulk modulus for a spherical object and it is subjected to uniform pressure. Then what is the fractional decrease in its radius? You are asked to decide. Okay. For that, you should know the mathematical formula for the bulk modulus. Okay. As you know, bulk modulus denoted with B equal to uniform pressure dividing by minus delta V by V. Because of the pressure, volume is decreasing. That's why minus delta V by V is the decrease in volumetric strain. Okay. From this, I can write that minus delta V by V is equal to uniform pressure divided by bulk modulus. Okay. But it is asking the fractional decrease in its radius. By the time the volume is decreasing, definitely radius is decreasing because the radius r equal to volume v equal to 4 by third pi r cube. Okay. Then what is the delta v? Delta v equal to 4 by third pi into 3 r square into dr. Then delta v by v is equal to 4 by third pi into 3 into r square into dr divided by volume is 4 by third pi r cube. Okay. Now let us simplify it. Here 4 by third is cancelled. Pi is also cancelled. R square cancelled. Finally, it is equal to 3 dr divided by r minus in the place of delta v by v. You can write 3 dr divided by r is equal to p by b. The negative sign indicates decrease in radius. Therefore, the fractional decrease in radius dr by r equal to p by 3 into b. That is the answer. Look at the option D. Option D is absolutely correct. P by 3b. Understood clearly? Yes. Then let us take the another important problem asking like this. The value of coefficient of volume expansion of a glycerin is 5 into 10 power minus 4 Kelvin inverse. Volume coefficient or coefficient of volume expansion given. Let me write it clearly. Coefficient of volume expansion generally denoted with gamma is equal to 5 into 10 power minus 4 Kelvin inverse. The fractional change in density of the glycerin for a rise of 40 degrees centigrade. Given that the rise in temperature delta T equal to 40 degrees centigrade. We are asked to decide fractional change in density. Okay. For that you should know the density and change in temperature coefficient of volume expansion relation. Remember density rho equal to rho naught into 1 minus gamma into delta T. From this I can write delta rho by rho naught equal to gamma into delta T. It is equal to gamma. Gamma is 5 into 10 power minus 4 into 40. 5 into 40. 40 into 5 is 200 into 10 power minus 4. It can be written as 2 into 10 power 2 into 10 power minus 4 equal to 2 into 10 power minus 2. means 2 divided by 100 equal to 0.02. That is the fractional fractional decrease in density or fractional change in density 0.02. It is option A is absolutely correct. Understood clearly? Yes. Then let's take the another important problem. It is asking like this. The Young's modulus of steel is twice that of brass. Young's modulus for the steel equal to 2 times the Young's modulus for the brass. That condition is given. Two wires of same length and of same area of cross section. Same length means length of the steel wire equal to length of the brass wire, and area of cross section for the steel wire equal to area of cross section for the brass wire. One of steel and another brass are suspended from the same roof. That means the two are suspended. The two wires are suspended from the roof. The same, right? The two. Let me mark the two are suspended from the same roof. Same roof. Let me draw it clearly. Both are suspended from the same roof. This is the one wire. This is the another wire. Another wire. That the first one is steel and second one brass. Okay. Then if we want the lower ends of the wires to be at the same level, lower ends at the same level means the change in length for the steel must be equal to change in length for the brass. That is the meaning of that particular point. That means if you want to lower ends of the wires to be at the same level, means change in length remains same for both cases. Then weight added to the steel and brass. Here weight is added for the steel. This is the weight for the steel, and this is the weight for the brass. You're asked to decide weight of the steel divided by weight of the brass. That is the question. For that, as we all know, the change in length delta L equal to what? General formula. Change in length delta L equal to force FL by A into Y. Here F means weight. That is W L by A into Y. Since delta LS equal to delta LB, change in length of steel equal to change in length of wire. I can write that weight of the steel into length of the steel divided by area of cross section for steel into Young's modulus for steel equal to weight of the brass, length of the brass divided by area of cross section for the brass into Young's modulus for the brass. Given that area of cross section for steel equal to brass, these two are cancelled. Similarly, lengths are equal. LS equal to LB. From that, I can write that WS by YS equal to WB by YB. From this, weight of the steel by weight of the brass equal to Young's modulus for steel by Young's modulus for brass. But it is given that Young's modulus for steel is 2 times the Young's modulus for brass. It is 2 times the Young's modulus for brass divided by Young's modulus for brass. It is equal to 2. So conclusion is weight of the steel divided by weight of the brass equal to 2. That is the answer. Okay. Otherwise, weight of the steel is weight of the brass is equal to 2 is to 1. 2 is to 1. Look at the option. Option A is absolutely correct. Understood clearly? Very, very important problem. This is the 5-star problem. 5-star problem means this kind of problem can be repeated. Okay.
Geobyte.